Now for the composition of functions, and the composition is when you insert one function into another. And we talked about at the beginning in the first video that you might see it as f with the little dot and then g, which is read f composed with g, or f of g of x in the parentheses, and that's read just like I did it, f of g of x. So either of those are equivalent to each other. They mean the same thing. So looking at our first example, we've got our f of x function is x squared. So we'll use x squared for that. And then our g of x function is the square root of x plus 1. So that's what we'll use when we have g of x. So my first one, and I prefer the notation of f of g of x. So that's how I would write it. That means the same thing. You can choose however you want to. But what this means is we're taking g of x. And so I like to write it out as g of x equals, and that's the square root of x plus 1. And then we're substituting this into our f function. So if we zoom out here, f is x squared. So I'm substituting the square root of x plus 1 in for where x is in my other function. So I write that out as f of the square root of x plus 1 equals, and then this would be the square root of x plus 1 squared. Because my f of x is just x squared. So I'm replacing the x with the square root of x plus 1. And then here we can simplify because we know squared means we're going to write it out twice and multiply. So let's see what we get here. Square root of x plus 1 times square root of x plus 1. Multiplying through, root x times root x is just x, or the square root of x squared, which is x. Here we get plus 1 root x, plus 1 root x, and then plus 1. So here we'd get x plus 2 square root x plus 1. All right, now what if we go backwards? What if we take g of f of x? So that means we would look at f of x first, which is just x squared. And then that would get substituted into the g function, so g of x squared. And just as a reminder, g of x is the square root of x plus 1. So we would substitute in underneath the square root with whatever we have here. Just like back here, maybe if I highlight, it'll help. Back here, we had x squared, and we replaced the x with the square root of x plus 1. So if I replace the x underneath the square root with x squared, here's what that looks like. We would have the square root of x squared, and then that plus 1 still. And then simplifying this, the square root of x squared is just x, and then plus 1. And there's our simplified answer there. So for these, it just takes practice and seeing different examples and asking questions. So if you have any questions on those, let me know, and we'll do one more here. Number 4. So here we're given two different functions. F of x is x plus 2, g of x is 4 minus x squared. So letter A, we're going to do f of g of x. So we're going to take g of x first. That is 4 minus x squared. And that's going to get replaced into the f of x function. So that's going to get replaced wherever we see the x. So it'll be 4 minus x squared and then plus 2. And simplifying, we can combine the 4 and the positive 2, so we get negative x squared and a positive 6. Now letter B and C, we are actually using numbers. So for letter B, we will evaluate f of 3. We'll do that first because that's on the inside. And so that would be substituting a 3 in for x. So 3 plus 2 is 5. And then we're using this answer in our g function. Just like in letter A, we used 4 minus x squared in our f function. Now we'll use the 5 in g, and we'll substitute the x with 5. So 4 minus 5 squared is 4 minus 25, which is negative 21. So when you have those numbers, just like before, you're actually substituting the number in. So same idea with C and D. So these would be two good ones if you're watching the videos here to pause and try them on your own and then check them with the video. So first for letter C, we take f of -2. So if we substitute a -2 in for x up here for the f function, we'd get -2 plus 2, and that's 0. So then 0 is what we're substituting into the g function. So g of 0 would be a 0x squared. So 4 minus 0 squared. And that's 4 minus 0, so that's just 4. Now letter D might look a little bit funny, but it wants you to do g of x and then of in the g function. So g of x. So what that means is we're going to write out the g of x function, which is 4 minus x squared. And then we're going to substitute that into the g function, and we're going to write it where the x is. So that would be 4 minus, and then 4 minus x squared squared. So you can compose a function with itself by substituting that function itself into the x value position. Simplifying, we'd get 4 minus, and then 4 minus x squared squared. I would be writing it out twice. 4 minus, and then multiplying. Notice how I'm going to keep my parentheses mostly and especially because we're subtracting. So then if I multiply here, I get 16 minus 4x squared, minus 4x squared, and then plus x to the 4th when I multiply. And then there's a couple different things you could do next. You could combine like terms. I'm going to go ahead and distribute the negative all the way through. So 4 minus 16, and then plus 4x squared plus 4x squared minus x to the 4th. And then I'm going to write this in standard form and combine what I can. So my largest exponent is that negative x to the 4th. And then we have two x squared values. So 4 and 4 is 8, x squared. And then we have two constants. 4 minus 16 is a negative 12. Okay, so there are a couple full examples of using composition.